All right, let's talk about Turing machines then. This is what we began talking about last time. I just want to do a bunch of examples today. Remember, a Turing machine has a diagram to it with states, and then it also has the tape, which sort of moves back and forth as it reads the input string, and it modifies the tape as it goes, or maybe it doesn't modify it. It can modify or not if it wants to. So we're going to do some very simple examples today, or sort of examples of increasing complexity. How about a Turing machine? I'm always going to write TM for Turing machine. For this language, AX, where X is in AB star. All right, so this will accept any string which starts with A. That's what that means, right? It accepts any string which starts with A. Accepts any string starting with A. How do we make that happen? Well, I would say, like, to describe in words what this machine has to do. Remember, you begin with the input string on the tape with the head pointing at the first letter. I would say if the first letter is A, it should be accepted. And if not, it should not be accepted, right? This is very simple. It's going to take basically just one step in the diagram describing the states. So here's, my starting state. And then if it starts with an A, it should be accepted. And remember, a Turing machine, when it ever enters an accepting state, it immediately stops. So basically, it's going to be this. This is the whole diagram, where that arrow happens if you read an A. Now, in a Turing machine diagram, basically I want this. But that's not technically allowed on a Turing machine diagram because every arrow has to be labeled with what you read, what you write on the tape, and then also which direction you move. Now, none of those things really matter in this example apart from what you read. But just because you have to put it in there, I'm going to write it like this. So that says if you read an A, then you should replace that with an A. In other words, just leave it like it is, and then move to the right. Now, you don't have to move to the right. You can move to the left. It doesn't matter. You got to do something, though. That's just how a Turing machine works. All right. What if you don't read an A in the first step? Well, then you should just get stuck, and the string should be rejected. And that's exactly what happens with this machine as written. So that's the whole thing. So if it reads an A from the starting position, then it moves over here and is accepted. And if there's anything else in the starting position, then it's not going to do anything, which means it will never reach the accepting state, which means the string is rejected. So that's probably the simplest example of a Turing machine we're ever going to see. Any questions about that one? This is the very simplest possible example. Let's try something a little more interesting. It's a little more difficult if it was something like XA. Then you're looking for the last letter to be an A. That means the head is going to have to move all the way down to the end of the string and check if the last letter is an A, right? That would be more difficult. Let's try something like that. Actually, this is slightly more complicated than what I just said. How about BXB, where X is in AB star? So this is a string which starts with a B and also ends with a B. So what the Turing machine is going to have to do is check that the first letter is a B, and then also sort of move to the right a bunch of times and check that the last letter is also a B. So I don't know about that, checking the last letter, but checking the first letter is easy enough. That looks like this. I'm going to do BR. Meaning, if the first, when you begin, if you see a B, you can just leave it as a B. I mean, it doesn't matter what you do to that. And then move to the right, just because you got to move somewhere. All right. But this is not an accepting state yet. If you make this accepting, then the machine will just stop and accept anything that starts with a B. But that's not good enough. In this case, we need to check that it also ends with a B. The idea would be move the head to the right over and over again until you get to the end. Unfortunately, there is no way really, because the head only sees one spot at a time. It can't really know if it's at the end or not. Anybody have a strategy? How could you make the thing figure out where the end is. I remember when I was a kid, I was trying to explain to my friend how to get to my house. I said, it's the last right turn on this road. And he naturally said, how do I know which one is the last right turn? And I said, oh, I don't know. How would you do it?
Could be when you get to blanks.
Right. You actually, in order to find the end, you actually have to overshoot the end, which you will figure out by seeing a blank, and then you go back one step to the left. So the way to do that, and this is actually a very common thing that you're going to do a lot when you are creating Turing machines, to do this or that. This state right here, I'm going to use to move all the way to the right. And the way that I do that is with a loop here, and I'll say AAR, BBR. So on that edge, the meaning of this right here is move all the way to the right. Pass every A, pass every B, and eventually you will get to a blank, which is after the input string. And I will say blank, blank, L here, BBL. Does that mean something? This is a new bit of slang that I've heard only very recently. I'm not sure what it means. It's some kind of plastic surgery, is that right? Yeah. I'm not really in that market. Not yet. All right, anyway, you go all the way to the end until you have overshot the end by seeing a blank, and then you go back one spot to the left. And now, once you arrive here, you should be pointing at the last letter, and I want to accept the string if that particular last letter is a little b. And if it's not a little b, like if it's an A, I should just, I suppose, stop and reject the string. So I am going to do like this. BBR, actually this R doesn't matter, but you have to put something there, and then it should be accepted. All right? So if I were to sort of annotate this a little bit, this moves all the way to the right. Then by doing this, we actually overshoot the end of the string. We go back one, and now this says, maybe I'll sort of point it right here. Now we're at the last letter. And if that last letter is a little b, then we go to the accepting state. This other stuff, BR here, doesn't really matter. It's just you have to put something in order to make it a legal step on your Turing machine. All right. Any thoughts about that one? I got one for you all to try. This is a very basic thing that we're going to do often, this kind of a thing, which is to move to the right, or sometimes you want to move to the left, past a bunch of stuff. How about you try, this is similar, although a little bit more complicated. How about A, B, X, C, Y, A, where X and Y are any strings in A and B. All right. So this is a string which begins with A, B, then has some more A's and B's, then has a C, then again has some more A's and B's, finally ending with an A. It should be similar to the one above, although you're going to have to do some extra stuff, I would say. See what you think. I'll give you a few moments and I'll walk around and see how you're doing. far. Mm-hmm. When you do this here, it won't actually make it all the way to the end. It will through that, like this, and yeah. So actually, I think you want it to, like this right here. Mm-hmm. This goes through any A's and B's.
Yeah.
Which is actually that's how you don't really want to say
Okay.
it should go through the X and then this right here should have something.
This literally
Um,
is not. You never even
All right, can we discuss this? I see some people did great. Pretty much everybody started it off correctly, which is you should begin by seeing an A, and I'll go AAR, and then a B, so I'll go BBR. All right, that is going to read the first A followed by the first B. And of course, if it doesn't begin with an A followed by a B, then the machine will get stuck immediately and reject the string, which is what you want. Now I'm going to try to move through the X. The X consists of a bunch of A's and B's, and the way to do that is like this, AAR, BBR. So that step right there is going to move to the right, continue moving to the right through the X. And then after that is the C. This step here actually does not make it all the way to the end of the string. It is only going to go through the X because the X consists of A's and B's. And then the C. So I want to move to the right past the C. I'll go CCR. And then I'm looking at the Y. I also need to move to the right through the Y, which is all A's and B's. So this will go AAR, BBR. Now this time actually it will make it all the way to the end. This will move to the right through the Y, but it will also move past this last A. And just to verify that the last letter really is an A and not a B, you need to back up that BBL. I move back to the left by one position, and then if it's an A, it should be accepted. So here, I go like this, AAR, I guess, and it's accepted. I hope that this is more or less what you did. So this first step moves through the first A, then past this, the next B. This business here moves through the X, then you have a C. This business actually moves through the Y and also the A at the end, because you can't tell the difference at that point while you're reading this where the Y ends. So you got to go all the way to the end, move back by one spot, and then check the last letter is a. All right. Any questions about that? I hope you got something like that. Great. Let's try something a bit more complicated. So one thing that you'll notice is none of these examples have modified the tape at all. And also these examples basically only move to the right. I mean, we had to move back by one spot to check the last letter, but essentially these do not move the tape back and forth, left to right, over and over again. That is sometimes necessary though, so let's try actually one of our favorite examples. How about A to the N, B to the N? All right. This one is going to be quite a bit more sophisticated. Another thing you will notice is those diagrams were not very interesting as far as the states. They basically all kind of go in a line. Sometimes you want diagrams which have loops in them. That's what we're going to do for this example. So you have to, it'll take a while to get used to, as usual. You'll have to learn how to think properly about writing Turing machines to do various types of things. And there's one very common sort of strategy that we're going to do. And here I'm going to use what I'm going to call a marking Turing machine. That is, as the machine goes, it's going to kind of mark off certain letters that are on the tape. So here's my, my strategy here. You read an A and mark it. And the way that I'm going to do that on the tape, this says read, I hope this is legible, read an A and mark it. That is to say, I will change it to, let's say, A bar or something. That will indicate, like, that's an A, but I already took care of that A. This is the idea. And then, you know, I imagine sort of checking this. A typical string in this language is like this, A, B, B, B. And the idea, watch me while I do this, is I read the string one letter at a time, and it's like, okay, I read the first A and I mark it off, and that has to match with the first B. And then I go back to the next A, mark that off, match that with the second B. Then I go back to the next A, mark this off, match it with the last B. And then if I end up having marked everything off, then that means it should be accepted. This is the idea of a marking style Turing machine. And this actually is a very sort of common way of thinking through things as we go. So I'm going to show you sort of the idea here is that the tape in steps will look like, you know, something like it begins with A, B, 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 and the idea is what I do first is mark off the first A, and then the head moves to the right past a bunch of unmarked A's until you see a unmarked B, and then it marks that. So the next stage would look like this, right? And I hope you can imagine the kinds of steps that you need to use in your Turing machine are like change a to a A bar, and then move to the right over and over again until you see a B, like that's not a B bar, and then change that B to a B bar, and then move to the left over and over again, back to the first unmarked A. So the next step will mark the next A, and then move to the right again and mark the next B. So now it'll say A bar, A bar, A, B bar, B bar, B, right? Move to the left again to find an unmarked A. So then it'll say mark that A, and then move to the right again to mark the last B, and so on. Well, actually, that's the end of this one, all right? And then maybe the machine will sort of do one last check through the whole string to make sure everything is marked. And if it's all marked, then it should be accepted. If it's not all marked, that would mean maybe like if there's like an extra A over here or something, then it's not all marked and the string should be rejected. Or maybe there were too many B's, an extra B that never got marked off to match a, etc. Anything like that should make the machine reject. All right? So this involves lots of moving to the right and then moving all the way back to the left, etc. Let's see if we can write down a machine that does this. So I would describe sort of the basic steps here are mark the first A, then move to the right, and then mark the first B, and then move to the left. And then sort of, you know, loop this, repeat that until the end somehow. We'll try and start working this out. Now, how do you repeat those things? In the states that I draw, it'll end up making a loop in the diagram. That's how you do this thing over and over again. Unlike, you know, these diagrams, they just went sort of in a line, my diagram is going to actually end up back where it started so that it'll go around several times. Let's see if we can do it. I'm going to start, here's my starting state. I'm going to make an arrow. Anybody want to suggest what the first arrow should say? You have to imagine you are starting off pointing at that first A. What should I do with that? I'll give you a hint. A. Yeah.
Should be A bar.
Mm-hmm.
And then, right?
Yeah, great. Yeah, A bar, R. So it's A bar because you're going to mark off that first A that you see there. And then R means move to the right. Now, actually, you need to move to the right probably many times. But, a great journey begins with one small step. So you should move to the right. All right? Now, in this step, what happens next? You should move to the right many times, like I said. So I'm going to do one of these things, which is to continue moving to the right. Now, you have to be a little bit careful about exactly sort of how far am I going to go to the right. In our previous examples, remember, the way to think about this is something like this means I'm going to move to the right through every little a, and in this example, also through every little b. So you have to think about what kinds of things do I want to move through as I'm going to the right. I would say, like looking at this, for example, we're kind of at this stage right now and pointing right here, I suppose. We have just marked off the first A, and now we're looking at this one. I want to move to the right. I would say you should move through any other unmarked A's that you see. All right, so I'm going to put AAR here. This means if you see other unmarked A's at this point, you should just pass them by. Really what I'm looking for is a B that's unmarked. Is there anything else I should perhaps be moving through at this point, passing by? I would say in this, like at this point, it's just little a's, and eventually I will end up at a little b. Actually, in more generality, if you imagine we're in some later step, like I said, this is going to end up making a loop here. So we're going to be doing this same process even later on, like for instance right here, after you mark the second A. You will notice as I move to the right, I have to go through one unmarked A, and also I want to go through this marked B. So in the first step, actually this is all you need, but in later steps, you will also want to move through already marked B's. All right? And so I'm going to put that one there also. As I move to the right, you have to imagine you're in a step like this. I just marked the second A. As I move to the right, looking for the next B, I have to move through a unmarked A and also through a marked B. You should not move through unmarked B's. As soon as you see an unmarked B, you've got to mark it. So I'm going to make another state down here. It turns out this whole loop is just going to have 3 states. And the arrow going down is, when you see an unmarked B, you should mark it. So that means B, B bar. And then which direction should I move at that point? Yeah, I think you should begin going back to the left. Remember, the strategy here is you mark a A at the beginning, then you go down to the right, mark off a B, and then you're going to have to go back to the left to find the next unmarked A. So this says B, B bar, L. All right? That's the first step to the left. Now, you are going to have to continue moving to the left. So you should imagine, say, at this point, I'm going to put some looped edges here because we're going to, it's not enough to just move left to one position. You have to move left several times. And you have to ask yourself, again, what kinds of things am I going to move? What kinds of things am I going to move through as I go to the left to find, my goal is to find the first unmarked A. Any thoughts? What should I put here? Yeah.
Mark B, mark A, and then A. Oh no, just mark B and A.
Yeah, so he says A, so it's going to be AAL. That is, I have to move through some unmarked A's because I'm looking for the first unmarked A. And then also you may, in later steps, you may be moving through other marked B's. So I also put B bar, L. like that. That is moving to the left through A's that are unmarked and through marked B's. All right. I would like to sort of move to the left until I find myself pointing at the first unmarked A, but actually we will again have this problem where you're going to be moving through these things, you're going to overshoot it, and eventually you will hit an A bar. That's your clue that you just overshot the first unmarked A, and so you should move to the right by one position. So it's like this, A bar, R. And then you will find yourself again pointed at the first unmarked A, which is why this makes a loop at that point, because you're sort of back to the beginning again. Well, it's not exactly the same as where you started because some things have been marked off. But this whole procedure is kind of one time through marking one A and matching it by marking one B and then going back to the beginning. All right. This is the basic idea. Any thoughts about this? This, in my opinion, is quite a bit more complicated than the other examples, but this is kind of the basic prototype machine that we're going to do. Like most of the ones that I ask you to do will somehow be modifications of this basic idea. All right. Now, we're not done yet. You have to say, like, when is this string actually accepted? So, anybody want to suggest? Like, at what point in this procedure will you realize that you're done? Yeah?
Is it the starting state? It's acceptance state?
Yeah. I think it is once you get back to the starting state is when you realize you're done, although you cannot make this an accepting state. Because remember, on a Turing machine, if you ever enter an accepting state, it just ends and is accepted. So if this were an accepting state, then every string would be accepted, which is definitely not what you want. But
Could you have an arrow from the first state saying that if it points to B bar,
yeah, right.
accepts?
Yeah, so this is sort of the trigger for being accepted in this machine is if you get back to the first state and see a B bar. That's because if you're actually all done here, what you end up doing is, like in the last step, you will have marked this B right here. And then you go back, so in this step here, in this state, you go back to the left, I suppose until here, when you reach an A bar, and then you move to the right one more time. You find yourself in the starting state pointing at a B bar. So if you ever find yourself in the starting state pointing at a B bar, that means that you've already marked all the A's and turned them into A bars, which basically means that you're done. Although, there is one little technicality. It is not necessarily accepted if you get back here with a B bar. That's because there could be extra B's that your machine has not marked yet, and in that case, it should be rejected. So I'm going to say, just put a B bar R here, oops, like that. There's one last thing we need to do, which is to go through the rest of the string and make sure there are no extra unmarked B's at the end. And if you think about it, actually, there could even be extra unmarked A's at the end, which definitely should be rejected. So there's a little sort of a cleanup stage here, which is from here, can I just say, maybe if I were to annotate this a little bit, this is sort of like the main loop here. This is where all the marking happens. You have to do a little thing at the end just to make sure there's no extra garbage left over in your string, because the string is supposed to have only this block of A's followed by the block of B's of the same length. So this last, I'm going to put sort of a little spur here. This is not going to have any loops in it, this last bit here, but this is kind of the cleanup, or the double check that there's no extra nonsense at the end of the string. So what I'm going to do is move to the right through any further B bars. There should be no A's or A bars or anything. And if we arrive at a blank, then it should finally be accepted. So this sort of cleanup step here is to make sure that there really wasn't any extra funny business at the end of the string. The end of the string at this point should consist only of B bars. No unmarked B's, and certainly no A's. All right? Only then do you know that the string should be accepted. Any thoughts about that? This is the basic Turing machine for A to the n, B to the n. One thing that this immediately tells you is that you can do non-regular languages on a Turing machine, right? A to the n, B to the n is a non-regular language, so the Turing machines definitely are more powerful than the NFAs and DFAs, although you probably guessed that anyway. I just wanted to do one more thing with this, just to make sure everybody still remembers. I'm going to try and copy this. I want to just write out a specific derivation of a particular string, just so that everybody remembers how we write Turing machine derivations. Let's derive, how about that same string, right? A, B, B, B. Now, as I'm going to write this like in individual steps, there's kind of a lot of steps because every single time that it moves one way or the other, that's a step. In order to write these steps, the states need to have names. So maybe I'll just call them 1, 2, 3, 4, 5. All right. And let's just make sure that this really works by writing a derivation. And I hope you all remember how we write the Turing machine derivations. So the starting form of the tape is this, A, B, 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 with a 1. That 1 indicates that we begin in state 1, and the 1 is to the left of the first A. Remember, the way that I'm going to write this is I just write the state as part of this string here, and whatever state it is represents where the head is pointing. So this says the head is in state 1 and is pointing at the first A. All right, and after the first step, we do this arrow in the diagram, which means the 1 will become a 2, and it will also move to the right, and also that first A will become an A bar. So it looks like this, A bar, 2, A, B, B, B. All right, the head moved to the right by 1 spot. It changed the A to an A bar, and it's now a 2 rather than a 1. All right, there's kind of a lot of steps, but we're not going to do this kind of writing out the derivations in detail very often, but just once in our life so that everybody is on board with this. So the next step, I have state 2 looking at an A. That will do this arrow here, which will keep the A like it is, move to the right, stay in state 2. So the next one looks like A bar, A, 2, A, B, B, B. All right, the 2 is still a 2, the little a is still a little a, and it moved to the right by 1 position. Next step is going to do the same thing again. The 2 will again move to the right by 1 position, and everything on the tape will stay the same. So now it says A bar, A, 2, B, B, B. All right, and now I have the 2, the head is in state 2 looking at a B. It should change that B to a B bar and then move to the left and change to state 3. This is a little confusing to hold all of that in your head at once, but I believe it has to look like this. A, 3, A, B bar, B, B. I changed the first B to a B bar. I moved to the left, and I'm now in state 3 rather than state 2. The 2 has become a 3 and moved to the left from where it was before. All right, now I'm in state 3 looking at an A. 3 has an AAL, so it should keep the A like it is and move to the left. So my next step is A bar, 3, A, B bar, B, B. I hope I'm doing all right. Again, I have 3 looking at an A. I do this looped edge again. The 3 moves to the left, keeps the little a, so it's now 3, A bar, A, B bar, B, B. And now in state 3, I see A bar. That means I go this arrow here, keep the A bar like it is, move to the right, and switch to state 1. So this is now A bar, 1, A, B bar, B, B. And we've gone sort of once through the loop now. It's kind of that 2 more times, and then the end. I said this is a little tedious, which is why we're not going to do these complete written out derivations very often, but that's how it goes. Everybody all right so far? All right, what's next? 1AA. So 1A, I'm going to do this arrow here. The A becomes an A bar, and then I move to the right and change to state 2. So this becomes A bar, 2A, B bar, B, B, like so. And now I'm in state 2 looking at A. That's a looped edge on the diagram, so I stay in state 2 but move to the right. So this is now A bar, A, 2, B bar, B, B. And now 2 looking at B bar. Again, that's a looped edge on the diagram, so I keep it as a B bar, keep it as a 2, move it to the right. So now A, 2, B bar, B. Oh, sorry, I messed it up. If I were to describe this, I would say it's not really hard, but it is very easy to mess it up, although you'll probably realize you messed it up immediately. All right, anyway, 2, looking at a B, I change it to a B bar and move to the left and change to state 3. That looks like A bar, A, 3, B bar, B. I changed that middle B to a B bar and then moved to the left and put it in state 3. All right, now I'm going to move to the left a bunch of times, right? State 3 has a B bar, L. So the first move to the left will be 3A, B bar, B. That was one move to the left. Next, 3 looking at A is another move to the left. So A bar, no, move to the left. So it's like that. A bar 3, A bar, A, B bar, B. All right. And now I'm going to do that diagonal arrow. I'm in state 3 looking at A bar, so it goes A bar, R. So and changes to state 1. So now it's going to say A bar, 1A, B bar, B. All right, and that's our second time through the big loop. One more time. Are you tired of this yet? Yes. 1 and A changes to A bar. Maybe I should have done AABB instead of AABBB. It's all right. It'll be fine. Put that in your course evaluation at the end of the semester. I will read it and I will slowly nod my head and say, yeah, maybe they're right. 1 and A changes to a bar. State 1 changes to a state 2, so now it's 2, B bar, B. All right, in state 2 with a B bar, I'm going to move to the right twice. A bar, B bar 2, B bar, B. That was once to the right, one more time to the right. A bar, B bar 2, B. Right? And now do the vertical arrow on the diagram. 2 looking at B is here, changes to a B bar. So it's A bar, B bar. Nope, actually it's moving, to the left. So it's now a 3, B bar, like that. I think I did that right. And then moving to the left again, because I'm looking at a B bar, and actually twice to the left. A bar, 3, B bar. Finally, 3 A bar. So I move to the left again. And then one last time, that diagonal arrow on the A bar makes me go to the right and change back to state 1. A bar, 1, B bar. All right. And finally now we're going to go down that sort of cleanup phase. When you're in state 1 and you see B bar, you change to state 4 and move to the right. So I go A bar, B bar, 4, B bar. In state 4, I continue moving to the right through any B bars. That will happen twice. A bar, B bar, B bar, 4, B bar. One more time. A bar, A bar, A bar, B bar, B bar, B bar, 4. And now I have 4 looking at blank, which means I go over to state 5, and this will be the last step. A bar, A bar, A bar, B bar, B bar, B bar. And I suppose I have moved to the right past 1 blank. And then I'm in state 5, so it is accepted. All right. Thank you for your participation and patience with this example. I just wanted to do one example. Like I said, we are not usually going to write down full derivations like that, but it's a lot of steps. Any questions about that? Maybe you'll do something like that once on the homework. That'll do it. Okay, we've got a few minutes left here. Could we try to make some simple modifications to this basic design and make it do different things? How about, I still have it. I'm gonna try and just copy paste the picture. Actually, maybe I'll redraw it, but what I would like to talk about is, let's modify it to accept, how about a to the 2n, b to the n? This one has twice as many a's as b's. So how could we change our marking strategy to make this happen? Twice as many a's as b's. Anybody want to make a suggestion? The answer actually will look more or less like this again, but it'll have sort of an extra little thing in it. Any ideas? You want it to make twice as many a's as b's. Yeah?
Could you just add an additional state with the A bar R before 2?
Yeah, right. She says basically you want to do that arrow twice. This way you're going to mark 2 A's and then mark 1 B, and then go back, mark 2 A's, mark 1 B. 2 A's for every B, right? So the idea here is 2 A's for each B. And the way to make that happen is basically this arrow right here, you do that one twice, which means you kind of insert an extra state right there with that arrow twice. So it's going to be, I'm not going to number the states this time, but my starting state, I go A bar R, that is mark the first A, and then do that again, mark another A. And then otherwise the whole thing is the same. I will fill in the arrows here. So after marking the first A, I go to the right through any other A's, also through B bars. When I see an actual B, I mark it and go left. Here, I move left through any B bars or A's. Here, if I see A bar, this is all the same. I hope that I'm remembering it properly. And then the end game here is B bar R, continue through more B bars, B bar R, and then this is a blank R. And this, did I write an extra state? Yeah, I don't need that last one. Excellent. So this accepts A to the 2n followed by B. All right. We got 5 minutes remaining. I had one for you all to try. Is it enough time? How about, we got 4 minutes left now. How about, again, this is something you can do by a fairly simple modification. Let's try AC to the n, B to the 3n. The way I would think of this in terms of the marking is, at the beginning you mark, every time you go through, you have to mark A with a C at the beginning. And then at the end, this should match up with 3 B's. That's how I would think this through. See if you can make the diagram for that. I'm going to write my answer slowly. Sorry, we only have a few minutes. It's not really enough time to walk around like I usually do. Can we talk about it? I know you're not done. There wasn't enough time to do this all together. Sorry. I'm trying to do this strategy that I said. Mark the A and the B, mark a A and a C at the beginning, and then match that by marking 3 B's at the end. So I hope that you started off like this. I marked the A at the beginning, followed by a C after it. That's a C, C bar, R. Now I have to move all the way to the right until I see some unmarked B's. This will involve moving through unmarked A's, also unmarked C's, and also marked B's that have been marked from previous steps. When I see an unmarked B, I'm going to mark it, and actually I want to do that 3 times. So when I see an unmarked B, I'm going to go B, B bar, R. I moved R this time. It was L in our previous examples, but I'm going R because I have to do 3 B's. So you have to keep on moving to the right to find the next one, and the next one, and the next one. A BBR, and a third. B bar R each time. All right. And then from here, we are going to move back to the left. Actually, that's the main change. The rest of the diagram will look the same as in the previous example. So from here, I'm going to move back to the left all the way until I get to well, we'll think about how far back do you want to go, but I have to go back through B bars, marked off B's, and also through unmarked A's and unmarked C's. All right, I believe when I go back to the left, the first thing which I encounter, which was already marked, will be a marked C, right? Because I've marked off A and C, and then A and C. So I go back to the left until I see a marked C, and that's my sort of signal that I'm back at the beginning, like that. A question? Yeah.
Why is for the last B bar R? Why is that an R and not an L?
Oh, I guess it could be a L.
Okay.
Yeah, that's probably better if it's a L. Although I think it probably still works either way. But yeah, that'll save you a little step. And then just to say the final run out here is the same as it was before. So if you see a B bar in this step, you go R. Then you just have to check that all the rest are all B bars until I get to a blank. That's it. Sorry, I went over by a minute or so, but that's how we do it. We will do even more fantastic examples next time.